Hello and thanks for watching Best Maths Tutors. This time we're going to cover algebra. I'm going to go through a series of topics on algebra, hopefully starting from the basic ones and working our way up. So I'm going to cover various topics in this, such as simplifying expressions, substitution, multiplying out brackets, and that can be single or double brackets, and then solving equations. And that can be all different types, such as linear equations, ones involving brackets, equations with the unknown, so that's usually x on both sides, non-linear equations such as quadratic equations, and creating formula. So there's many different topics under algebra at GCSE, and I'm just going to cover a couple of things before we start. So this is basically the meaning of some expressions. If we've got an expression, it's when it's just saying something in algebra that might not be actually an equation, which would involve an equals. So an expression could be if I write down something like 5x, and I want to just explain what that means. So 5x, actually when I've got a number and a letter next to each other, actually means 5 times x. And we do shorthand there by not putting a times in between. And the reason is because if we had put the times in between, it might look a bit like an x, so we could get a bit confused. And if in fact we have several letters put next to each other, for example, A, B, C, in algebra, that would mean A times B times C. So the shorthand there is not putting a times in between the letters, but we do mean that. We mean A times B times C. Another important thing is we can't simplify by adding unlike terms. In fact, putting that the other way around, we can only add like terms. So what that means is if I took an x and another x and added them together, I would get two x's. It could be something like I've got an apple and another apple, and I add them together and I've got two apples. But if I add an x plus a y, I couldn't do anything with that. So they would be classed as unlike terms, and I can't actually add them together. So all I can do is just keep that as x and y. So I can't simplify this one, whereas I was able to simplify this one. So the first thing I'm going to look at is just simplifying or collecting like terms. And this could also be known as simplifying expressions. So I'm going to take this one, which is probably a simple example. We've got x plus x plus x plus x. So if we were to ask ourselves, how many x's have we got? When we do that, we've got 4 x's, haven't we? So we've got 1x plus another x plus another x plus another x. So the total number of x's we've got there is 4. So we can write that as 4 x's. I'm also just going to point out that an x on its own is the same as writing 1x. But it's because we don't need to write the 1 in front of it, we know that x just means 1x. So we tend to simplify 1x by just writing x. But exactly the same thing for this would be to write 1x plus 1x plus 1x plus 1x equals 4x. But as I say, when there's just a 1 in front, we don't tend to write the 1. Now I'm going to look at this next example here, and we can see this time we've got an x plus 2x plus 5x, take away 3x. So we just add them together by adding the numbers in front of them. So we can see we've got a 1x there, plus 2x plus 5x, so 1 plus 2 is 3, plus the 5 is 8, take away 3, so take away 3 x's, and that would take us back to 5x. So that's that one. Now, the next example that I've got here, we've got a combination of x's and y's. So, as I said before, we can't add x's to y's. We can't add things that are different. So we can only simplify like terms. So the like terms here are the y's and the x's. And then we've got just a number on its own there. So what I'm going to do is I'm going to rewrite this by shuffling the numbers. I'm going to take the things that are like each other, like the y's there, and move them almost as though they're counters. So I'm putting the things that are like each other next to each other. So I've got 3y, and I'm going to move the y, and it's very important to move the sign that's attached. We can think of the sign in front of the letter as being attached to it. So that becomes 3y take away y. Then the next thing I'm going to do is I'm going to take plus 6x. I'm going to write that there. And I'm going to take the 2x and I'm going to write that there, including the sign that's in front. And then I've just got this plus 3. And I'm going to write that at the end. So now I've got that, I can look at the like terms. So we can see in terms of the y's there, I've got 3y's take away another y. So if I do that, 3y take away y is 2y's. Just like thinking if I've got 3, if y represented an apple, I've got 3 of them, and then I'm going to take away 1. So cross 1 off, and I'm left with 2 of them. So I've got 2y. Then I'm going to look at the x's, and I've got plus 6x and plus 2x. So if I add 6 and 2 together, I'm going to get 8. And then the 3 on its own, that's considered as different to x's. So I can't say that a 3 is a like term to either the x's or the y's. So really, I've just got to treat the number on its own. So that's just going to remain as a 3 because there's nothing to add that to it. And that would be the answer to that one. We can't go any further with that. So now I'm going to look at one that might look a lot more complicated, but the same principle is going to apply. So that is that we can only simplify like terms. So I'm going to try and find the like terms and put them together just by moving them around as though the counters on this. So I've got 3x squared and 5x squared, and I'm going to take I nearly missed that off there. I've got a plus in front of it. That's got to go with it. So I'm going to take the 3x squared and I'm going to add to it 5x squared. Now, you might think, and it would be a very easy mistake to make, that the x is the same as an x squared, but it's actually, in terms of algebra, it's not. So we can't actually say that the x's are like terms to x squareds. They're totally different. We can't add them together. So the next thing I'm going to look at is the y squareds. I'm going to look at y squareds now. That 2 there, by the way, means squared. So if I look at that, y, that would mean y squared. And what squared means is times itself. So that would be y times y. So that's the meaning of that. In this question here that I've set up for simplifying this one, we don't have to worry about that too much, but we're just interested in collecting up the like terms. We're not trying to multiply it at the moment. That's just what it means. So we're taking the y squared and we're finding the other y squareds in that. So that's there. So we can put them together now. So we've got plus 4y squared minus 3y squared. So there we go. And now we're going to look at the x's. So we can see that we've got 7x there, and we've got plus 4x there. So we're going to write them next to each other. So that's going to give me plus 7x and plus 4x. And then we've only got this number at the end, minus 2. And because it's not attached either, because it's not multiplying an x or a y squared even, it's just a number on its own. There's nothing else that we can add that to, so we'll just tag it on at the end there. So now what I'm going to do is I'm just going to add or subtract, if it says subtract, the things that are like terms. So we've got a 3x squared and a 5x squared there. So what I'm going to do is add them together. So I'll get 8x squared. So 3 plus 5 is 8. So we've got 3x squareds plus 5x squareds gives us 8x squared. And the next thing we're going to do is we're going to look at the y squareds now. So we've got 4y squareds take away 3y squareds. So that's just 4 take away 3. So that's going to give us just 1y squared. Now, I could write it as 1y squared, and if I was on an exam, that would still be right. That would be correct. But just for simplification, what I'm going to do actually, I'm going to get rid of that 1 in front, and that can just be written as y squared, because 1y squared is actually the same as y squared. We'll just simplify it by not writing the number in front. So that's the y squareds done. Now we're going to look at the x's. Remembering the x's aren't the same as x squared, so they're not like terms with the x squareds. So the x's are like terms with only other x's. So 7x plus 4x would give us 11x. And then we just take the minus 2 there and just write that on the end. There's nothing to add that to or take it away from. No other like terms to the minus 2. So all we can do is write minus 2. And there we go. So the next question we're going to look at, we've got a mixture of ABs, BCs, A's on their own and B's on their own. So I've just added this one in to cover all the possibilities of sorts of questions that we might have. So just going to explain first of all what does 5AB mean. So if we remember from up above, if we have a number and a letter next to each other, then really what we're saying is between them we mean 5 times at A, and then a letter next to each other, again we mean times, so it means times B. So that's what that actually means. Okay. Now I'm looking for things, again, collecting up like terms. So we have to remember that ABs are not the same as BCs, and they're not the same as A's on their own or B's on their own. So we've actually got to look for exactly ABs when we're looking for the thing to collect it up with. That's AB. There. So first of all, I'm going to write the 5AB and the 2AB next to each other. So I've got 5AB plus 2AB. So they're next to each other now. And not forgetting to take the sign that's in front. I will say the first one on the line, we can actually, unless it says otherwise, we can assume that it's plus, a positive. So the next thing we're going to do, going to the next one, we've got BCs. We're looking for any other BCs in here. So we've got 2 BC there, or take away 2 BC. So we've got plus 3 BC. So that's that one, including the sign. And then minus 2 BC. Got to write the C there. So there we go. Minus 2 BC is here. And then we've got plus 3A next. So we've done those two, the BCs. Now we've got plus 3A. And there's no other A's there. So we can only write the A on its own there, 3A. So that's that one done. And we're going to do the plus 3B next. So we can do that plus 3B. There we go. So now what we're going to do is just collect up the like terms. Well, collect them up, I mean simplify by adding the like terms. So we're going to say 5AB plus 2AB is going to give us 7AB. Then we're going to take 3BC there, and from it we're going to take away 2BC. So if we've got 3 BCs and we take away 2 BCs, then we must have 1 BC remaining. And I'm going to rub out that 1 in a minute, or simplify it on the line below, but 3 BC take away 2 BC is 1 BC. And then we've got the 3A, and there's nothing else, there's no other A's on their own, so I can only write 3a. I can't simplify that at all. And then we've got plus 3b. So I'm going to write that there. But we can't do anything else with the b. There's no other b's to actually add it to. So the next thing I'm going to do is this is correct at this point. That's the final answer if we want that to be. But it just looks nicer to get rid of this 1 here and just write it as 7ab plus bc plus 3a plus 3b. And that's it. So I hope that's been helpful to you. And if it has, please like our video and subscribe to our channel to see all the rest of the videos we're going to do on this subject, and indeed all the rest of the videos we're doing on maths in general. Thanks for watching.